Okay, guys, welcome to today's meeting, the last kind of full instructional meeting for the semester. Today we're going to be going over our 10 rules for debugging. Um, and if that will click. So a few announcements first. Next Tuesday, we're going to be doing our lightning talks and elections, and that will be our last actual meeting of the semester. We will have pizza, and the all-new SSD shirts are finally in, so be sure to stop by for those if you want to pick those up. Invite your friends, and also run for an officer position. We have two of our longtime SSD veterans leaving us in Ranger and Eric. So we're always looking for kind of the future of SSD, and we'd love to get some new people on board. All right. So the first thing I'm going to ask is if you don't already have NPM and VS Code installed on your computers, go ahead and get that done now. We will be running a demo at the end of this presentation where we'll be showing you how to set up the debugger in VS Code and doing just a short little demo with it. So if you don't have those installed, no problem. You should be able to get that done by the time we get through today's presentation. Okay, so the very first question we want to ask is why are strong debugging skills important? Now, this probably seems like a really dumb question at first. Like, if you're writing code, you need to make sure it works properly. But the thing is, when you're a professional software engineer, people can often underestimate how much time you actually spend debugging. When you start, um, you're just kind of code all the time. You're getting it right. Not just something you do when you mess up, but debugging is a major, major part of maintaining software. You're gonna have to resolve bugs that maybe other people on your team introduced, bugs that were found in production and reported by a customer. Maybe the service you're running goes down during a critical hour and you're on call and you have to go and fix that. And that's a serious problem because when you have a production crash like that, every minute that bug's not getting fixed, the company is losing some serious money, and it's your job as a developer to make sure that gets fixed. So, a very, very large part of maintaining software is knowing how to fix the problems that show up on it. Now, the thing is, you know, going into a small kind of lab you did for programming one and debugging a large full scale production app are two totally different beasts. There's so many different interconnected components and services and everything that if you don't know what you're doing, you're going to be in for a really rough time. And while not every situation is going to be the same, I'm going to be going over just 10 general tips that might help you have an idea of where to start. And hopefully, if you apply these more, you can fix your bugs faster and more efficient. So, rule number one, the anticlimactic, but prevent bugs before they happen. So, good coding practices do wonders to prevent bugs. And I'm not going to focus too much on this whole thing specifically today because, the whole mission statement of this club is writing correct, maintainable software. If you kind of follow the best practices that, we talk about week in and week out, it's going to help you not just prevent bugs from popping up in the first place, but when they do pop up, it's going to be a lot easier to fix, right? So having more modular readable code, if you separate your code into components based on what each thing is doing, then when something breaks, you're going to know where to look because you don't have okay, the part of my chat app that handles user profiles is also for some reason mixed up with the part of my app that is actually sending the sockets to somewhere, or probably not the best example, but you know what I mean. You want to have separation of concerns as much as possible. You want your code to be readable because, for one, you're going to be writing code that the rest of your team will have to maintain. Um, and your teammates will be writing code that you will have to maintain. Um, it's not going to feel so good if you're in a situation where you're fixing a bug introduced by someone who quit 3 years ago and they all use a bunch of three-letter variable names like they're a C developer in the 80s. So module readable code. Be very careful with things like side effects. Highly recommend Blake's talk on functional programming from a few weeks ago with some concepts on that. It's up on our YouTube. perform comprehensive testing, static analysis tools, things like SonarQube, ESLint. They can catch a lot of potential problems with your code before they happen. And even sort of simple things like using IntelliSense in your IDE or editor, and not ignoring warnings when they pop up. They all do wonders. So, number two, time is your most valuable asset. Now, I'm sure y'all are used to hearing this a lot. You want to start as early as possible on really any kind of programming work. And this is especially true with debugging because as the amount of time left decreases, the less options and resources you have available to you. So examples of this, if you need to ask someone else for help, right, and you've got something, a deadline due in 30 minutes, you can't expect them to be available for you and drop everything to answer your question in that time frame. So, you know, and that kind of goes on to other things as well. If you need to talk to a TA for office hours, again, you got to go on their time and kind of schedule yourself for that. If you're working in industry and let's say you're in a situation like where I was this summer, I had a remote internship. Company was based on the West Coast. So if I decided to get up and do early morning work around, let's say maybe 9 a.m., I know the rest of my coworkers wouldn't be on until at like noon at the earliest. And that would mean that if I had a problem, I'd have to wait for their time. So, you have to respect people's time. And the best way to do that is to give yourself enough time to kind of factor in for these kinds of things. Now, that means when you're planning a project, you need to factor in extra time for fixing potential bugs. Some people will say you want to give yourself twice as long as you think it might actually take you. I'm not going to throw out any numbers. It really depends on how experienced you are in a stack you're working with. If you're learning a lot of new concepts, then you're definitely going to want to factor in more time for that. And probably the biggest benefit of giving yourself time is the ability to take a break whenever you get really stuck on something. Because I guarantee you, taking a break, walking it off, doing something else for a little bit is always going to be more productive than just staring at the screen, completely confused with a bunch of brain fog. So again, time is our most valuable asset here. Less time you have, the less a lot of these tips are, you're going to be able to take advantage of some of these tips. So before we kind of go on to number three, I just want to do a quick review of the two categories of bugs that we commonly have. Um, there's syntax errors and logic errors. So syntax errors are simply just that your code breaks the rules of the language. Class example, forgetting a semicolon. These are typically much easier to spot and fix on logic errors because oftentimes, most of the time, in fact, your code won't even run, right? And usually those static analysis tools, like we mentioned, if you haven't tell us something like IntelliSense on your IDE, it will catch that and let you know before you even run your code as you're writing it. So that's kind of the easier stuff to deal with. We're going to be more focusing on fixing logic errors in this presentation. Now, this happens when your code follows the rules of your language, but it gives you an incorrect result. So, for example, dereferencing a null pointer, right? So these are much harder to fix because your program can run anyway and run into it. And sometimes they might throw an error or exception, which can give you some helpful info, and we'll go more into how to take advantage of that info later. But sometimes it might not throw an error. And this could become problematic because now you have some piece of incorrect state in your program that's going to propagate through the rest of your app and then cause a whole bunch of other anything else that depends on that to also be wrong. So again, we're mostly going to be talking about logic errors today. So rule number three, really, really big one. Debuggers beat print statements as you scale. So print statements are kind of the old tried and true, most used method for debugging. Writing one is fast and convenient, but writing many is really tedious. It adds up over time. And the problem with this is sometimes you think I'm just going to write one print statement, right? And then you realize you need some more info. So look at the next variable over. Okay, I'm just going to write this instead. And do that with the next variable, the next variable, the next variable, and so much. And the next thing you know, you spent the last hour spending about like 25% of the time actually, thinking through the logic for your code. And most of that actually just writing and taking out your print statements. So if you're working on a very large, complicated app where you have a bunch of variables and things all over the place, it's not very efficient. Um, it's also the case where you might forget to delete them. If you do, you'll have to add them again. If you do delete them, you'll have to add them again if your fix it work. And you're like, oh no, I need those print statements again to look at my app state again. And this is a bit rare. I haven't heard of anyone actually doing this, but if you're on some kind of user interface and you log something and forget to take it out and potentially log some sensitive information, that could be a security vulnerability. Now, realistically, if you're at like a company, that should get caught in code review and should never happen. But I could imagine that might happen if you're working on a personal project. So be careful about that. So print statements can be problematic when you're working on large code bases. Um, the answer to that are debuggers. Now, I'm sure most of y'all here are familiar with the basics of how a debugger works. It allows you to instantly look at any state that's in scope at a particular point in a program's execution. It's great for those complex problems where you have to look at various different variables at once. If you need to see all the local variables that's currently in scope for your function, um, see what the values are for any objects that are currently being used. You can look at that all at once and it allows you to step through code line by line so you can see exactly when values are changing and when a bug occurs. Now, code editors typically don't have debuggers set up right out of the box. And that's kind of the reason why a lot of people might be hesitant to use them because if you're not familiar with how to set them up initially, you might not think that the upfront cost is worth it, kind of short-term investment versus a long-term gain. If you take the time to set up a debugger, it will really pay off in the long run. And if you're working in an IDE, like this is IntelliJ debugger here, it comes with a debugger right out of the box, and highly, highly recommend if you have that just to use it. And one other kind of point here, having a bit of a brain fart, but um at a point, I'll come back to it later. We'll move on to the next slide for now. But the $1 million question is when are debuggers most worth it, right? So really, anytime you're going to be using the same tech stack for an extended period of time, it's worth getting that debugger set up. So if you have any kind of medium or long-term project, you probably set up a debugger for that. If you're in a class where you're going to be using the same language or tools for the whole semester, you're probably going to want to set up a debugger for that. If you're at your job and uh, you're semi-consistently using a certain stack or whatever, and especially you're on some big piece of enterprise software, you want to set up a debugger for that. Some other situations where this could be useful is if you're inexperienced in a certain tech stack that you're trying to learn, just having that aid by your side when you're learning something can kind of speed up the process and allow you to spend more time focusing on the concepts and what mistakes you made instead of trying to find them. And this is a kind of niche one, but if you have a hackathon coming up and you know what stack you're going to use, then you might want to put in a debugger for that because the time you might save to fix any problems that might come up could be the difference between you polishing a feature or adding a new feature that could lead to you maybe placing or winning a prize. Now, that being said, print statements are not the devil. You just don't want to overuse them. So they can be very useful for situations where you want to visualize the way data changes over time. Now, I've kind of got a leak code problem as an example here. It's Pascal's triangle. Basically, the way this problem works is you want to go and print every row in a triangle. And this is a case where printing might work because you can kind of see the mathematical relationship that comes about between all the variables. Like, okay, middle connection that you might not be able to make by just looking at the variable change one at a time in the debugger. So that could be helpful right there. They also drawing on print statements can also be okay for small throwaway projects that or something that's in a stack that you're not really going to use again. perfect example of this was actually our Git workshop from earlier in the semester. So we rewrote that in Python for all the programming one kids. And personally, I'm not using Python for anything right now. And the whole thing was maybe like 40 lines of code total. So that's a situation, right, where it's not really worth it to set up the debug. Now, rule number 4, live reloading makes you faster. So live reloading basically reloads your app anytime you make a save to your source file, so you don't have to do it manually. And this really helps you with being able to make small incremental changes, which is a crucial thing for debugging. And honestly, that could have been a slide on its own. You don't want to change too many things at one time whenever you're debugging because you kind of need to isolate your variables here, right? So if you're changing multiple things, you're not going to know what it was that you fixed or what it was that caused the bug. So try to make as few changes at a time as possible, ideally one change at a time. Live reloading really helps with that because you don't have to go to the process of going back in your command line and stopping your program and recompiling it and rerunning it and doing that all the time. Um, Live reloading, you just save, it reruns your app. And that really helps you with kind of iterating through those small changes faster. Now, hot reloading is a special type of live reloading that saves your app state and updates your app with the new code without actually restarting the whole thing. Now, if you've ever worked with React and it started with Create React app that uses hot reloading, um, that is very useful, although you do want to be just a bit careful sometimes with that. The reason why is if you're changing your code, right, and then you hot reload, it might be possible for your program state to get to a point that wouldn't be possible for an actual user because you went and changed the code while it was running and then you kept that same state, right? Um, so just to keep in mind, sometimes you will need to do just a full page refresh or something like that. But aside from that, hot reloading could be is very useful, especially for user interfaces, because you don't want to have to go back and navigate all the way to whatever page you were on before. Whenever you're making changes to a web page, for example. Now, some common tools for live reloading. If you're doing Node backend apps, NodeMon is a very popular one. We're going to be demonstrating that in our demo today. Apparently, you can also use that for Python as well. I've never tried it, but the internet said so, so it must be true. TS Node Dev is basically NodeMon, but for TypeScript and Node projects, and a live server does live reloading for vanilla HTML, CSS, JS projects. So, rule number 5, don't let your thoughts go straight from your head to your code. So, it's really easy to skip a step without realizing it, especially if you're rushing or you're kind of making jumps in your logic without really realizing it. Now, one thing you can kind of do to combat this is to voice your thoughts out. Some of y'all might have heard of rubber duck debugging before. It kind of comes from the idea of holding a little rubber duck and basically talking to it and trying to sound your thoughts out. So it's basically just talking to an inanimate or possibly animate object to voice your thoughts out. If you have someone who's willing to listen to you talk about your code, good for you. That's a great friend. You should keep them as a friend. But most of the time, you probably don't want to board the non-technical people in your life with that. So having a rubber duck to kind of sound your thoughts out and make sure you actually sound sense is very useful because frankly, if you can't put your ideas into words, then are you really going to be able to put it into code, into correct code at that? Not to mention that thinking out loud is great practice for communicating with your coworkers, right? You're going to be in meetings where you're going to have to discuss technical aspects of something, or even a really niche thing when you're doing technical interviews. Aside from getting the question right, probably a second important thing you can do is to be very vocal about your thought process and kind of think your thoughts out loud. So, kind of learning to kind of voice your thoughts out explicitly is a huge step in making sure that you don't make any jumps on logic, that you don't make any assumptions that you shouldn't have. And something that I think might even be better than writing it out, than talking out, is writing it out. So one thing that I like to do a lot is just have a separate text file open in another window. If I'm in VS Code, I'll just open up a split window and have a text file there. And basically what I'll be doing is just I'm writing down what I'm thinking, which files, variables, methods am I looking at. Um, and the great thing about writing it down is, for one, it allows you to easily retrace your steps later. And this, again, is crucial because you don't want to kind of have that eureka moment where you're finding like, oh yeah, I found where this bug is. And then soon as you start implementing it, you forgot the steps you had to take to get there because the code base is, too complex. So allowing you to retrace your steps later is huge. You can also, again, kind of coming back to our earlier point, if you have a chance to walk away and take a break, you can reread your notes later to check for flaws in your logic. It's kind of like the same way when you're proofreading an essay, right? If you read it right after you wrote it, it's going to look all good. But if you come back to it, an hour or two later, a day later, you're going to notice, oh, yep, I used some wrong grammar there, messed that up. So again, write it down, gives you a chance to review it later. And something else is that it's actually makes it easier to turn your notes into documentation when you're done because you don't have to revisit everything. You kind of have a record of your thought process of everything you did. And that can kind of make that process a lot less painful because I know as developers, a lot of us might kind of dread the thought of writing documentation. Um, so this kind of streamlines the process and it just kind of makes it into a part of your debugging slash coding slash thinking routine. So rule number 6, understand the tools that you're working with. Now, you can't fix something if you don't know how it works, right? And a really common way to introduce a bug is to incorrectly use a feature of a language or framework. So this is kind of draw on our previous JavaScript workshop from Eric. Let's say that function is calling an API call, calling a GET request to somewhere. Now, as you can see, it's giving me an incorrect result. Can someone tell me what's wrong with this here? Well, what right. So I should have clarified that. Right. My API call is like some kind of string. I remember that Kanye REST API from a few minutes ago where like we called an API that gave us like Kanye quotes. I guess imagine us doing that. So we want to get some kind of string return from our API, but it's returning undefined. Um, and kind of the reason I'm using this example is because this is a mistake you might make or a bug you might fail to notice if you don't know your JavaScripts properly. So basically, wait a minute, hold on. Result. Actually, no, that's not. I thought you almost had you almost used my own slide against me there for a second, but I realized no, the variable isn't being reassigned there, so that's right. Um, but what's wrong here is that hmm, no. So base yeah, exactly. Yeah, so yeah, like Alex said, this needs to be an ace for one, get API call needs to be an async function, and we need to await that when we call value from API. So again, if you're not familiar with JavaScript, you're not familiar with the concept of async await and callbacks and stuff like that. If you saw this, you wouldn't be able to figure out what's wrong with it. And we had evidence here. So again, you really need to understand the tools you're working with. And I actually have one more kind of weird example of something that happened to me when I was interning that kind of hammers this home. So I was running some unit tests on some SQL queries, and the test kept failing, and all the parameters had the right values. I couldn't figure out why. It turned out, right? So for our SQL queries, we didn't use raw strings. We used something called a query builder. It's not an ORM. If you ever use those, it's not that. It literally just kind of builds the query strings from some function calls. And basically what happened was it was rearranging the orders that each like row in the database query appeared in. Now, this broke my unit test because when I wrote the unit test compares the strings for each query. I wrote the string for the query to match the order that I typed each value in my code. But because the library itself was changing that without really any kind of notice anywhere, it caused the query strings to be unequal and my unit tests were failing. And that wasn't even in the documentation. I had to do some kind of deep digging again with the debugger, looking at the values of the query string variable as I was doing the breakpoints. And again, I know that now because I had to go in and learn that aspect of a pretty somewhat niche library very much in depth. Um, so again, long story short, the more you know your tools, the more power you're going to have to fix any problems that you might have. So rule number 7, this goes hand in hand with rule number 6, understand your code base. Again, you can't fix something if you don't know how it works. So the kind of two key questions you need to be thinking about when in the broader sense of your code base, right, is how/where is data moving through my app? And specifically, where is my app state changing value? More specifically, where does it go wrong? Where does it take an incorrect value? Because if you find that, you basically find your bug, right? So again, this is kind of like an oversimplified example of what the architecture for a front end app might look like. You have your user interface, and then usually you click on it, you fill some forms out, whatever. That will get sent to some kind of data store in your app, if you're familiar with Redux. And then finally, when that needs to go to backend, it will go out through some API call. And then data that comes in the other way, let's say you fetch something from the backend, okay, it's going to go to part of my app that handles the API calls and go to where the data store is, and then finally come back to my front end components on the React side. So again, you need to know kind of where it's moving in your app. And with this knowledge, it kind of leads us into a general roadmap that you can take for finding bugs. And this was kind of a approach that I used a lot while doing a lot of debugging over my internship. First thing I would do is typically start from where the bug presents itself. So again, if you're on some kind of front end app, this is typically going to be on a component that's showing the incorrect value or the component that's not displaying correctly, right? So what you want to do is go to that component in your code. And then again, the backend equivalent of that is if something's wrong with your backend query, it would be from wherever your API controller is and you have that route, right? So again, let's use a front end example because I think it's a bit more intuitive for this. Let's say you have the wrong value component. You pull up that component in your code, find out what variable has that wrong number. Okay, we found that. Now we want to start tracing our steps back kind of through the path that data took to get here. So that incorrect value, where did it come from? Did it come from a function parameter, a class member variable? Okay, we'll go there next. Now, after you do that, you'll see where that got its value from, right? And then you basically keep working backwards, and you want to try to keep a point, basically notice each point where the state has potential to change. And you basically want to do that until either A, you reach a point where you already know that the state is correct. That can be from looking at the values in your debugger or any other way that you might have deduced that, or a point where the state is directly coming from an external source with no intermediate steps. So if you're on the front end and you trace your incorrect state all the way back to the API call on the back end, more likely than not, it's a back end issue. And I say more likely than not because nothing is absolute when you're debugging, right? If you trace that value all the way back to a database call, well, maybe there could have been something wrong with the database or maybe a problem with inserting that into the database. So again, you kind of work backwards until you get to that point where kind of, I can't really trace this back any further. Once you've done that, and again, taking notes kind of helps here. You want to retrace your steps back to where the bug presented itself. So again, with the front example, let's say we worked our way all the way back to the API call. Now I want to go ahead, retrace the steps I had, try to put some breakpoints on each spot where I think the state might change. And then what I can do is after we've traced our steps back, set our breakpoints, we can do is start running our program again, stepping through them. What our debugger pull up, look at the values that each variable has. Keep going until we see something start to go wrong. And once you've seen something that's not adding up, something that seems to be an incorrect result, you know you're getting closer to your bug. Uh, and again, this might seem like kind of a bit of a convoluted process. And it is much easier kind of set up here than done. You definitely get a lot better and faster at this the more knowledge you have of your code base, which is kind of why this comes after this slide, right? For a big complex system, there's a lot of moving parts. The way things are stored can take a lot of time to get familiar with. And again, what we said earlier about having clean modular code uh, also plays into this as well. If you have kind of a bunch of spaghetti code everywhere and you're trying to backtrace your steps through that, it's going to be harder to find certain things, right? You know, sometimes if you see that a variable in your UI is wrong, right? Let's say something that, let's say you have some kind of online game and you have some kind of score calculator, right? And the score is wrong. Well, instead of maybe tracing your steps back, you know that has to be coming from the score part of your data source. So you can maybe just go straight there and look there instead. And these are the kind of things that you get more of an intuition for the more familiar you are with the code base. Right. And then rule number 8, know how to use error information. So again, sometimes with logic errors, you'll get an error, sometimes you won't. If you do get an error, you want to try to get as much information out of that error as possible. Now, one approach that we've all probably done at some point is try to Google the exact error message you got, only removing the things that are specific to your project, right? So any kind of variable names, class names, file names, anything that you know no one else has, you don't want to include that in your Google search because you want it to be narrow enough to find your problem, but you don't want to kind of exclude anything that can help you out. Now, just in case anyone here doesn't know this, if you put quote as your search inside of double quotes in Google, it will return an exact match for that text. And that is extremely useful because oftentimes other people are going to do the same thing. They'll have the exact same error message you did. They'll make a post on Stack Overflow with that. And someone with a lot of experience will go and answer that question. And all you have to do is find that post. So if you're lucky, this approach can really save you. A lot of the times it won't save you though. It's okay. Um, and again, one of the reasons why we kind of want to give ourselves time, right? Try to read the solutions you find anyway. It might be a bit hard to understand, but try to take from it what you can, because they might give you relevant context to figure out what's wrong. And again, if you have enough time, maybe read some surrounding documentation on what related things are coming up with that error. Could be a good learning opportunity for you to kind of learn your code base and tools more, which again, it's kind of like a feedback loop. The more familiar you become with everything, the lot faster and easier it's going to be for you to fix bugs going forward. So, oh, and one last thing that I almost forgot. I think, yep, it's on the next slide here. So stack traces. Oftentimes when you do have an error, you're going to get something called a stack trace. Now, is everyone here kind of familiar with what a call stack is? I'm guessing we all are. So yeah, basically a stack trace just prints out your entire call stack at that point in your app's execution. So it'll give you basically every function that's been called to get up to that point and the line numbers on which they were called. Again, this could be very useful for kind of retracing your steps faster. If you have this information, maybe you won't need to do the steps where you're backtracking through like 1,000 lines of code just to get back to where your state originally came from. So if you have this information, it's very useful. Another thing also is try to pay attention, especially if you're using external libraries, where if something might be saying there's something wrong with an external library. If you're using a reputable library, something like, React or Express, it's very, very unlikely that the bug you're seeing came from that library, right? Now, it's possible, just extremely unlikely, and I can't speak as much for kind of smaller, less reputable libraries, but if you're using the kind of big, famous, common ones, most of the time, if you see those libraries on your call stack, then you can just kind of skip them, right? So, for example, let's say if this was calling something in your node modules, right? Again, kind of going back to our JavaScript workshop, node modules is where you have all your JavaScript dependencies. So if you see something in your calls like this says node modules, you can kind of probably skip past that line and go to look at the next line of code that you actually wrote. So, um, yeah.
If I could comment on what I said there, that sort of reminded me of something that actually happened to me before with Create React app. Literally the day I decided to React, I got this weird error message that said it couldn't download this TypeScript lint package, and I had no idea what was going on. The guy that I was watching, he was doing it just fine. I had no idea what I was doing wrong, and then I checked the actual GitHub of that package, and it actually said that there was like this huge error. And on the NPM website, there were zero downloads of this program, and like literally zero. So it was like seriously not working. So one of the few times that I guess a reputable package like this straight up failed.
Yeah, that's kind of a hint towards what the last slide is, which might seem like a bit of a contradiction, but we'll get there right after this, which is rule number 9, ask for help, right? So again, the whole thing where we stress trying to give yourself time, again, you got to respect other people's time. So if you need help on a class assignment, right? Talking to your TA's professor, going to office hours can help. Also, you speaking with friends, using whatever resources are available to you within what's academically allowed, right? Personal projects, you can pretty much do whatever you want with that, but asking a friend with experience in a domain is very helpful. Um, and then anytime you're at work, asking someone more senior is huge. And something I really want to hammer here, especially for anyone who might not have had an internship before, um, when you get there, don't be afraid to ask lots of questions. I know you might be worried that you're going to come off as annoying or kind of constantly being on your senior's back. But the thing is, it's expected of interns, completely expected. It's completely expected of juniors, especially when they're just starting out, and sometimes even seniors. I've recently heard of figured out like at like big tech companies, they don't really expect you to be a meaningful contributor for something like 6 months at least, because it takes that long just to get acquainted with the code base and everything. So, you know, there's no such thing as a dumb question when it comes to this stuff. And asking them these questions could be a great opportunity to learn more about the code base. I had times during my internship where I'd ask a question about maybe some part of our main backend service, right? And then my seniors are telling me, oh no, that problem is actually happening because of something involved in this completely different service over here, which they ended up teaching me about, and I ended up doing work with that soon. Heck, there was even this one specific bug I was trying to fix that I thought was a smaller thing. It turned out I ended up having to migrate an entire route from an old service to a new service because the old service wasn't equipped to handle some new functionality that the new service had basically introduced. So the way it worked is they were using kind of both these services to do the same thing, trying to retire the old one. But again, there was no way I could have figured this out without asking my seniors. So I learned a lot about the code base kind of from getting that. And again, moving forward, I was able to kind of find and fix these problems a lot faster. And then kind of tying back to what Brian was saying, rule number 10, expect the unexpected. So this kind of has a few meanings. One is you don't really want to make any kind of assumptions about your code, right? Bugs can really come from places that you never imagined that they would have come before. Again, it's why it's so important that you want to sound out your logic as much as you can. Take a closer look at everything, something that you might be thinking, oh, of course I did that right. And then you didn't do it right. And it turns out it might have been what's causing your bug the whole time. So again, like the example I just had where I thought I had an idea for a fix for a bug at my internship, turned out it wouldn't have been possible to work because the service I was working on was missing the functionality it needed entirely. So again, sometimes these bugs can kind of just come out of left field. And if you're trying the previous steps and you're not necessarily getting a clear resolution, again, try to take some time from it. Maybe this might be the time to ask for help, think outside of the box, um, and just know that these tips are not necessarily one size fits all. Um, while code is different from app to app, service to service, company to company, and you never know what kind of problems you're going to run into next. So again, this is why I kind of say 10, I say 10 rules for debugging. This should really be more 10 tips for debugging. You really have to just use your best judgment here and kind of set yourself up to succeed as well as possible. And again, something else that's unexpected, kind of like what Brian was alluded to, sometimes it's possible your code is correct and the bug is caused by something external. Now, again, other bugs in other components and code that you didn't write yourself is a bit rare, but it's very much possible. Probably the most common of these is bugs in another service in your organization. If you're working somewhere where you have a microservice architecture and you're sharing services between different products, right? And some kind of functionality service. Well, if there's a bug there, then it's going to affect you. So at that point, maybe you could use that as an opportunity. Talk to someone on that team. Say, hey, I think there might be a problem with your code here. Maybe would you want to look at it? Might kind of show yourself as a self-starter at your company. And then again, there's the other things like bugs in external APIs, broken dependencies, and then really the last kind of bug, specifically, it's not necessarily a code bug, but things like server, internet, and connectivity issues which, at least in my experience, are a bit more common than someone else's code got messed up, right? So again, one thing you've probably heard is DNS errors cause a lot of problems, right? Um, one specific really strange thing that happened to me this summer, I was working on a Discord bot and I was trying to hook it up to a MongoDB instance in the cloud to store server settings. And what happened was when I tried to connect the bot to the MongoDB server, it just would not connect. The connection refused. I couldn't figure out why. I redid everything like maybe 4 or 5 times. Nothing changed. And then like 3 days later, I find out what happened. I found out that what happened was port forwarding was being blocked on both my Wi-Fi and on my VPN. And the thing was, the VPN is kind of normal because they don't want people to use their service to, go and transfer a bunch of information like that. I guess I'm not a networking guy, but my the fact that this was happening on my home Wi-Fi too was also coincidence. My apartment had like just changed management, and they were doing weird things, like putting random filters on stuff. We couldn't even play Minecraft or Terraria. Those ports were blocked for a bit, and it was just a coincidence that that was blocked at the same time as my VPN. And I didn't realize that was a problem until I thought to get on the UF VPN like a few days later. So again, my code was completely correct the whole time. And again, more so something this is more so something like a server slash internet issue here. One kind of final note about those kind of really weird bugs is they're usually typically harder to reproduce, right? So if I had, picked up my laptop and maybe came to school library at any point, then my bot would have just started working and maybe I would have made a connection a lot sooner. Maybe I wouldn't have, but I know that I would not have been able to reproduce the bug on campus because the connection would not have been blocked, right? So again, crazy things can happen. So you sometimes you just need to brace yourself. Again, all the things I talked about previously, giving yourself time, learning your tools, learning your code base will make you more prepared for when these really bad bugs start to happen. and hopefully you'll be a bit more prepared going in to kind of deal with it. So finally, it's time to go ahead and get into our demo. So what I'm going to be going over here is basically just how to set up a simple Node.js debugger with VS Code and just kind of give a short little example of some of the tips that I mentioned, like the thought process and whatnot. Um, Now, again, I'm kind of doing VS Code for this because, like I mentioned, if you're someone who's used to having that IDE where your debugger is set up for you the whole time, um, and as you can all see my screen there. I need to change my screen share to VS Code on Zoom. Yeah. But again, if you're used to kind of having that IDE where everything's already set up for you already, and you move to something like VS Code, which is the standard for most of web development, then you might be a little intimidated by first on how you're going to get the debugger set up, right? So, um, yeah. Uh, First things first, actually, there is a GitHub repo. This is just a pretty simple node project here, but probably should have put this on the slides. We go to, it's going to be github.com/ufssd/debugging-workshop. So again, this is linked right there. If you just copy that and then git clone that into the directory. It's a pretty simple just npm project setup, a single file to go over some things. Uh, Basically, the file has a few functions, some bugs in it. We're going to get our debugger setup going and then go and debug them. So uh, for one, does anyone need any more time to kind of get the link down? Right, does everyone have the link for that? Awesome. If you go ahead and clone that repo into your VS Code, we're gonna have this, right? So it's just your package JSON package locked in a source file. Again, like I said, got some functions here that have some bugs in them that we're gonna try to fix. First things first, we need to get everything set up properly. So the first thing we're gonna do is, I mentioned live reloading earlier. It's a very useful tool for speeding up your process, allows you to make small changes quickly. And since this is a Node.js app, we're going to be using NodeMon for this. So we'll go ahead and install that right now. It's pretty easy. You just go into your project directory, the same one where you have your package JSON. So let me cd into workshop. Awesome. And all we're going to do is type in npm i -- save dev nodemon. And then basically that's going to take some time to install that for us. Again, we're using save dev because we only need this dependency in development, right? The user won't need nodemon on their end. And no, I'm not updating that. So now we've done that, we can go ahead and just run npm i again and make sure we've got that installed. And now we need to get that set up. So if you go to your package JSON, you'll see that we have our start script here. Typically what I like to do is just use a separate script for dev purposes. So let's go ahead and, again, in package JSON scripts, I'm going to create a new script called dev. You can call this whatever you want. I like to just call it dev. And then what we're going to call for the script is going to be nodemon, and then wherever your entry breakpoint is for your app. So in this case, it would just be nodemon src/index.js. Again, it's basically just a start command I have here, but add the mon to node. And we'll go ahead and save that. So now if I come back to our debugging workshop file here, and then I type in npm run dev, we now have nodemon running, and we now have Vive reloading on our app. So again, if I come to the index.js file here, let's say I change our error message. So let's change that to say hello world instead of just hello. You'll see as I save, it's going to refresh, and now just like that, our new output is here. So all we did was just type our change, save it, and it automatically reruns for us. No having to go back to the terminal to type in, compile this or that, and then running it again. Just change it, save, and you're good. So now that we have our live reloading set up, we want to actually get our debugger set up. So VS Code does have a debugger, and it actually works pretty well with Node right out of the gate. And there's 4 different ways that you can launch the Node debugger from VS Code, and we're gonna go through all 4 of those ways. So, first let me probably just close the app real quick. Controls. So the first way you can do this is through the JavaScript debug terminal. So first things first, let's go ahead and set some breakpoints, right? We want to find somewhere to stop and look at our code. So let's go ahead and set a breakpoint on line 6, line 3, 4, and 6, right? Now, if we just run this as it is, the breakpoint's not going to do anything because we haven't attached this to our app yet. So what we're going to want to do is, if you go to the left tab here, hit run and debug, and you'll have some configuration options in this corner here. Now, let's see, hit the wrong thing there. You might have a big button here that just says launch and debug. If you haven't run it before, you can go ahead and click that. But basically, you want to come to this drop down here, and let's see. Am I missing the JavaScript debug terminal? Now, disclaimer, I had to completely reinstall my VS Code right before the meeting because it was crashing and not letting me open my terminal. So, let me go ahead and just make sure that's not like an extension I need to reinstall. Let's see, doesn't look like that's missing right now. So I'll go ahead and skip.
You can try deleting the launch that is on
Anything here? I'm gonna go ahead and just save this now so I can show the other demonstrations, the other 3 ways to start it without breaking any of those. Let me just make sure it's not because I pre-selected the breakpoints. Okay, yeah, so we'll kind of just move on to the next one by now, but typically in your drop down here, what would happen is you'd have an option called JavaScript debug terminal. You would click that, hit run it, and then in your debug console here, it would show you the output for basically your Node app, and that would allow you to step through the debugger as you would in an IDE, right? So again, there's 3 other ways that you can go about getting this launched. So the next way is auto attach, and what auto attach does is it basically automatically launches your debugger anytime it detects you running that process from a terminal, right? So again, I have the Node debugger. If I have auto attach enabled and I run a Node app in my terminal here, it's going to detect that and then automatically launch it. So you hide that again. So what you're going to want to do is open your preferences. You can do this by holding down Control Shift P. And then once you've done that, again, Control Shift P, you're going to type in auto attach. And then right here, toggle auto attach. So you'll have a few options here. You're going to want to go with smart. The always option that attaches to every Node.js process launched in the terminal. Smart only attaches to processes that aren't in a Node modules folder. And like we said earlier, Node modules contains their external dependencies, so you're typically not interested in looking at those. So you'll just want to hit smart. And let's see, we can see down here that auto attach is enabled. So if I go ahead and run my Node app again, let me see. I'm also realizing I need to set my breakpoints again. Uh, there it is. I forgot this. Yeah, so as you can see, I have an exclamation mark right here. I need to reload the terminal. So basically, I can just kill that and open up a new terminal. And this should now. Oh, okay. I did not CD into the right folder. Go run that. And there we go. We now have a functioning debugger in VS Code for our Node app. And again, this works the same way as a debugger would in an IDE. You can skip to your next breakpoint. You can individually step over into different lines of codes. You can view all of the current state that's in scope right here in variables. And then you can also view your call stack, pretty standard stuff for using a debugger. So I'm gonna go ahead and just it's gonna Control C out of that to kill the process. Now the other two ways that you can start this, and again, if you want to turn off auto attach, you can either Control Shift P again to and search for that to toggle it, or a bit quicker, you can just come down to the bottom here, hit auto attach, and just disable it again. So nice. Now we can also, this is a bit more of the old school way to do this in VS Code. You can use something called a launch configuration. Basically, you have a file called launch.json where you store your information regarding this. So again, we're going to open our preferences to get to this. So it's going to be Control Shift P, and then we're going to look for launch.json. And let's go open launch.json. And this is basically going to be our configuration here. So if you don't have it already, this will be stored inside of a folder called .vscode in your project directory. If you don't have it already, it should be created whenever you do this. So again, if you just Control Shift P and then search for launch.json, even if it does just click on it anyway, and it should give you some kind of blank template. Now, I already filled this out to show you what this might look like. And again, for Node, they kind of give you all the right information already. Now, this is the same process that you would use if you wanted to set up a debugger for another language, like Golang, for example. Now, you would need to find some more specific information related to that language through some expert Googling, and again, any other resources you might have. But when you do that, that information is going to be stored in here. And so basically, I have two configurations set up right now. We're going to focus on the first one. So type node, because this is node process, request launch, and a program. This is going to be our workspace folder. Again, because the launch.json is stored in the .vs code folder inside of our project folder. And then it basically just takes you down to the entry point for your program. So now to actually get our debugger working with this, we're going to come to the Run and Debug tab again. here in a drop down, we're gonna want to hit launch program. And then when we run that here, it's going to show up in the debug console. Now keep in mind, when I start it like this, it does not show up in the actual terminal because we did not start the app for the terminal. It's going to show up in the debug console. And again, any kind of changes that we make here will show up. So if I say that again, actually not sure if changes from NodeMon will show up on this simply just because yeah, I typically use the last method here because if you notice this isn't working with NodeMon. So we kind of lose live reloading when doing this. So there you go. That's kind of a downside to this method. So the last way you can set up your debugger here is by attaching to a process, which is the most involved, but it also kind of gives you the most control, and it allows you to directly attach your debugger to something else that's running in the terminal. And this is useful for if you have something where you just want to run your program at first, and then you change your mind, okay, I want to debug this now. You can just attach it to it, right? So what we're going to do is start your Node app from the terminal. So let me go ahead and just stop my app here. I think, okay, yeah, the program ended, so that's already stopped. So let me come back to our normal terminal. Again, let's do npm run dev, start our nodemon. And then now with that process running, what we want to do is go and hit the attach to program option. Now, this requires a config just like the launch program did. So again, to do that, you're going to want to go to your launch JSON folder. So again, that's going to be in your preferences. You can access that by Control-Shift-P. Search for launch.json, open that. And we're going to make a second configuration. You can see here our configurations is a JSON array that stores the settings for each configuration. When you first create this, it will only come with one. The default type is going to be the launch configuration, which was the last one we demonstrated. So you're basically going to create a second entry in this array here. And for the node debugger, you would have type node, again, because it's still a node program, request attach, because we're attaching to our existing program, a name, again, attach the program, skip files. And then the last thing here is called process ID. Now, this tag here allows it to automatically find whatever node processes you might have running and attach to those. If you're using something other than Node, you will have to find your app's process ID manually. And depending on your setup, that could be easier or harder. Personally, when I set this up with a Golang debugger at my internship, that we use had a proper name. So I was able to just search it up by the name instead of actually having to know what the process ID was. So making sure you're executable. Specifically for not even executable because this is interpreted, but making sure your program has a name associated with it can make that process faster if you're using something other than Node. But if you are a Node, you can just use this command pick process thing here, and it will just give you a list of your running Node processes. So now that we have this added to our launch.json, we'll just save it, come back to the index.js file here. And then let's see, I don't have the debugger running right now. So what I'm gonna do is hit attach to program, click play, and here's saying find a node.js process to attach to. And right here, it's just called node. So again, the name doesn't tell me much, but I can tell it's mine because it's running in the directory where I have my project. So we'll go ahead, click that. And then bam, we now have our debugger set up again. So I'm just gonna up our breakpoints are still there. I'm gonna change something to trigger nodemon again. And then now we've hit our breakpoints. So those are I guess the three ways you could set up a debugger to work with VS Code. Um, Again, if you kind of have the knowledge of what you're doing, it's not as intimidating. Um, and now really the last thing to do is just kind of give a very small example of what a workflow might be for winter debugging. So what I have here, these are basically just three LeetCode questions. It's literally just reversing an array, fizzbuzz, and returning a cube of a number. But they all have something broken with them, and we're gonna try to fix them. So let's see. I guess we can kind of go ahead and start from the first one, which is a reverse array. So if we look here at our output for this, let's see. Actually, that was not first. Okay, I output on the third power first. So let's say we have a number called 4, and I want to cube it at. Now, 4 to the third power is 64. I hope it is. I hope I remember how to do math, but I know that our program is saying that 4 to the third power is 16. So again, oversimplified workflow here. What I'm going to do is, before I do anything, I'm going to go ahead and just open a new file. Again, writing your steps down, your thought process as you go along is very helpful. I'm going to split this right so it's out of my way. If you have something like dual monitors, you can maybe have this open in a separate window or notepad or anything like that. And then again, let's follow kind of workflow that we went over earlier. So find where the bug kind of introduces itself. Now, in this case, it's coming through our, not our UI, but our command line. So we want to start from where this is logged. Console log, cube, and right here. So we know this console log is where we're going to be starting. So I'll say start from like line 29 or something like that. Now I'll see it's calling cube n. So we know it's coming from the function cube directly. So I'm going to say, let's look at cube. And then if I come right here, now this is a pretty simple function. We can return math power n2. Well, if we're looking for the cube, then it's going to be to the third power, right? So we kind of found the source of our bug here. Again, it's a very simple example here. We go ahead, change that again, and run that. We now see, hold on, Mom, 4 to the third power is 64. So again, we were able to make that change instantly, save it instantly. We didn't have to go type in anything and restart it. It's just right there for us. Now let's go ahead and fix the next thing. Reversed array. And let me save that again because okay, the debugger breakpoint was here. Turn that breakpoint off and then play it again. So reverse array is 0, 1, 2, 3. Well, the input I had here is 0, 1, 2, 3, so it's not reversing. Something's wrong with this function. Um, so again, let's kind of take our steps and work backwards. So the value is we didn't store in any variable beforehand. We're just getting it straight from the reverse array function. So okay, I want to go and look inside there. So now I'm just going ahead reading through this, trying to see if one is the overall approach for this off. Now, again, I kind of stole this from a LeetCode problem. If you've ever done like the two-pointer solution to this, it's a pretty famous problem. So I'm looking here. First thing I want to see is where is array being changed? So we know this is our return value, return ARR. Now I see right here that ARR right, so an element is being changed here, ARR left, an element is being changed here, here, and here. So I might just want to write those line numbers down as a point of reference. Now that I've done that, I can kind of come back up here and just check the overall logic for my function. Now, since this is an array, are we going out of bounds? Now, the left starts from 0, the right is the length minus 1, so we shouldn't be going out of bounds. Bounds look good. And then I'm looking at this while left is greater than right. Let so-and-so go forth. We see it swapping. I kind of think through some more. I'm not really sure what's going on here, right? Well, let's say I could go ahead and add the breakpoints now. So say I want to put one right when we enter the loop. We see 789 is where we make some changes, so we can add some there. And then also we can kind of just compare return value afterward. Let's not add that. Now let's go ahead and save it again. Okay, so we've got to our first breakpoint. Let's go ahead and step forward again. And what happened? It skips right over it.
Expect the unexpected.
Thank you. Thank you to the Microsoft. Thank you to the Microsoft gods for making my presentation more entertaining. All right, but something weird happened here. We ran this, and it didn't even execute the other 3 points here in the other 3 breakpoints here in my function. I just click step, and it goes right to the return value. So I'm thinking while loop is being skipped, the condition must be evaluating the false, right? Because otherwise it would execute the code inside. So now let's go ahead and look at our condition. Well, our condition is while left is greater than right. So now if we, again, kind of think about the logic for this problem, and again, writing your thoughts down helps. Again, let's say we have our example array 0, 1, 2, 3. We have our left should be at 0. Right should be at 3. And we're going to increase left and decrease right until left is and we will do that while left is greater than right. But wait a minute, left is 0 and right is 3. So is left greater than right? Nope. Meaning, and if you think about it for a second, it would make sense you would expect left to be smaller. So let's say, I hit the wrong key and just didn't notice that. So let's go ahead and flip that. And let's do while left is less than right. Now let's go ahead and save our changes. And oh yeah, save changes, make sure we step through everything. Again, this time we're actually stepping through. So we now know we got past the problem of basically our condition not evaluating. If I look at my variables here, I can kind of see what array is at each point. So let's say we go here, we go through one iteration of the loop. We successfully reverse the left and the right indexes. So we'll go through again. We see they swapped again this time. Now we hit return and it looks like we have the correct value. So we let it go forth. The reverse array is 3, 2, 1, 0, and we know it works. And yeah, I had a third function here, FizzBuzz. I think I'll kind of get the point now, and it is 7:30 already, so I'm gonna go ahead and kind of call it quits there for now. This I guess last kind of thing is okay, I meant to make that full screen. But that is it for today. Does anyone have any questions or comments or suggestions?